Hello everyone. So in the continuation of the previous video, what we are doing, we are learning how to draw the body plot. So we have already seen this body plot, right? In the previous video, this one. Then we solved a question. We have seen the basics concept of body plot as well. We have seen that a 0 will give you 20 dB per decade slope and a pole will give you minus 20 dB per decade slope. Okay. I would like to add one more point here. 1 0 will give you 20 dB per decade slope. N zeros will give you N zeros will give you 20 NdB per decade slope, right? And similarly, I wrote a pole gives you a slope of minus 20 dB per decade. Similarly, N poles give minus 20 NdB per decade slope. Okay, so let's solve this question now. So what we do first, we find the DC gain. So for DC gain, what we do, we put omega equals to 0, right? So my DC gain would be 1. Okay, then we find the location of poles and 0. There are no poles, only 0 is there. What is the location of 0? That is minus 1 by 2. Now I will draw the Bode plot. Okay, since there is a DC gain, so initially it will start from DCA. Okay, but at omega equals to 1 by 2, since this value is negative, but here we will write only positive values. So at omega equals to 1 by 2, look, I will tell you one thing. When you are drawing the Bode plot, all the poles and zeros should be in the left half of the S-plane. Okay, Bode plot is valid for minimum phase system. Bode plot is valid for minimum phase system. Now what is minimum phase system? So I won't go into the depth, just you need to remember that for minimum phase system, all the poles and zero are in the left half of S-plane. So all the values will become negative only. If any value you are getting, if any pole you are getting positive or any pole you are getting negative, that means you can't draw the Bode plot for that. You can draw the Bode plot, but it is not defined. What you can do, you can get the gain and draw it, but it is not defined. The Bode plot is only defined for a minimum phase system. That means all your pole and zero should be in the left half of S-plane. That's it. Okay. So Bode plot is defined only for the system where all the poles and zeros are in the left half of S-plane. Okay. So yeah, since you have what you have a DC gain first at omega goes to 0. Yeah, this is 1, and what is 1? 1 is 0 dB, right? So this is 0 dB actually. So instead of that, I can make it like this. Since this is 0 dB, so I will make it like this. This is 0 dB, and then at omega equals to 1 by 2, at omega equals to 1 by 2, you have a 0. That means 0 will give plus 20 dB per decade slope, right? So it will give you a slope of plus 20 dB per decade, like this. It will rise like this. Okay, I shouldn't like that. Just I will write 20 dB per decade. Okay, let's move on to the next problem. This is the problem. First, find the DC gain. For DC gain, what you will do? You will put omega goes to 0. So DC gain would be 10 into 4 by 10 into 2, right? So it would be 40 by 20, that means 2. So it would be 2, that means 20 log 2, that means it would be 6 dB. So DC gain is 6 dB. What is the location of pole that are minus 2 and minus 10? What is the location of 0? That is minus 4. So tell me, how will the Bode plot look like? This is your gain in dB, and this is your omega. So initially you are having a 6 dB gain. Initially you are having a 6 dB gain. Then what you encounter first? A pole or a zero? First you encounter a pole, right? So if you encounter a pole, that means you will have a negative slope. Now where will this 4 come? Where will this 4 come? At this point or at this point? That means at omega goes to 4, your gain is positive or your gain is negative. That I need to check. Okay, so I will have to check it. So at omega equals to 4, my gain would be tan into 4 into root 2. This would be root 16 plus 4, root 20 into 100 plus 4, 116. Okay, so I need to find out this value, and then I will get to know that if my gain is positive or it is negative. Okay, what I can do, I can make it root 10, 1160 under root, and reciprocal into 40. Yeah, so it is positive. Actually, you are getting, if you are getting value greater than 1 in decimal, if it is greater than 1, that means it is positive in dB, right? And if it is less than 1, that means it is negative in dB, right? What is the value of 20 log 2? That is 6. What is the value of 20 log 1 by 2? That is minus 6, right? So very basic thing. So you are getting it positive. So basically your 4 will be somewhere here. Okay. Now what is happening at 4? Here you are having plus 20 dB per decade. Now tell me what is happening at 4? You are having a 0. So tell me what will be the slope at 4? Initially you are having plus 20 dB per decade slope, right? Now at a 0, here you are having a 0, so you will have a slope of minus 20 dB per decade. So your total slope will be 0. Did you get this point? Let's just assume you have two graphs, y equals to 5x and y equals to 8x. Okay, y equals to 5x looks like this, and y equals to 8x looks like this. Okay, this has more slope. So this is 8x, this is 5x. Now I ask you to add both of the graph. What you will do? Add both of the graph. The graph will have a slope of 13x. The slope of 13. Right? So whenever you are adding graphs, your slope will be added. If if this 0 was not there, if this pole was not there, what would have been the graph? This would keep on going on like this. This would keep on going on like this. Now, what is happening? There is a 0 coming. That means this is plus 20 dB per decade. That slope is there. Now this slope will also come. So plus 20 and minus 20, it will make 0 dB. Okay, and till 10 it will go. Now till 10, what you are having? Plus 20 minus 20, that means 0 dB, and at 10 you are again getting minus 20 dB. That means again you are getting minus 20. That means your slopes will keep on adding. Okay, your slopes will keep on getting add, right? Oh, this was minus 20. Sorry. Here I said 20 minus 20. Here I said like this. I'm really sorry for that. Pole will give you minus 20 and a 0 will give you plus 20. So it will become 0 here. Okay. So I wrote like this 20 minus 20. That was wrong. Pole will give you minus 20 and 0 will give you plus 20. So 20 minus 20 plus 20 will be 0. So this is minus 20 and this is 0 dB. And then again minus 20 dB per decade. Okay. So the slopes will keep on adding up. Okay. So to make you understand better, I can take one more example. Rho Bode magnitude plot for is equals to tan s plus 2 s plus 4 upon s plus 1 s plus 3. Okay, 80 it is giving me 80 by 3, or forget about it. Okay. So what we will do? First we will find DC gain. What is my DC gain? My DC gain is 80 by 3. It will be something in dB. It will be something in dB, or I can find it as well. 80 by 3 log 10 into 20. It will be 28.5 dB. Okay. Now what is the location of pole? That is -1, -3. What is the location of 0? That is -2, -4. Now tell me, how will the graph? First you are having a DC gain. Well and good. So start with the DC gain. Okay. That is 28.5 dB. Then what do you encounter? You encounter a, this is the location. You encounter a pole first. So pole will give you -20 dB per decade. And then at 2 you encounter a, at 2 you encounter a 0. So this will give you -20 dB per decade. Okay. Then you encounter a 0 here. So I need to find whether this value is positive or negative. So it will be 10 into 2 root 2 into 20 upon 2 root 5 plus 9 plus 4 root 11. Did I do the calculation right? Yeah. This will be root 8 only. 16 plus 4, 20. Yeah. 160 by 55 under root into 10. Yeah. So we are getting a positive value only. This value is positive only. Okay. So now you are encountering a, 0. So that means -20 plus 20. Basically this you will get. Right? Then you are encountering a pole again. If you are encountering a pole again, -20 plus 20, that means 0 dB, and then again -20. So again it will go down. And at 4 you are encountering a, 0 again. Okay. So at 4 you are encountering a 0 again. Right. So this is how the graph will go. 0 dB. This is 0 dB per decade. When I encounter a pole again, so -20 plus 20 -20 again. So -20 dB per decade. The slopes will keep on getting added. Now -20, and then again I am having a 0. That means it will again add 20. So it will be 0 dB per decade. Okay. Well and good. Let's move on to the next question. Okay. So what is the DC gain? 20 by 45. 20 by 45 log 10 into 20. DC gain is -7. Okay. DC gain is -7. Now I will not care much about the magnitude. Okay. I will just care about the shape. How will slope 20 dB plus 20 dB, 40 dB, minus 40 dB. So I will just care about the shape now. Okay. So DC gain is -7. Forget about this. I need the location of pole. So what is the location of pole? There are two poles at -3, -3, -3, and -5. You can see. What is the location of 0? The location of 0 will be -2. Okay. The location of pole is -3, -3, -5. Location of 0 is -2. Well and good. So how will the graph go? It has a DC gain -7. Okay. Then what do you encounter first? You encounter a 0. That means now I don't care about the I don't care about what will be the value at omega goes to -2 or omega goes to -3. I don't care about it. I just need the shape. Okay. So what is the slope here now? That is plus 20 dB per decade, because I am encountering a pole here. This is the pole that I am encountering. So this is a 0 that I am encountering. That is 2. This is the gain in dB, and this is the omega. Okay. So first I am encountering a 0. That means I am getting plus 20 dB per decade. Now I am encountering two poles. Okay. So first I was having plus 20 dB per decade. Now two poles are there. That means they will give you minus 40 dB per decade, right? One pole give you minus 20. Another pole will also give you minus 20. At the same location, they will give you minus 40. That means I will have a slope of minus 20 dB per decade now. Got my point? And I don't know what point I will reach. It will be lower than this or higher than this. I don't really know. Okay, I know this. How do I know this? You need to tell me. I am saying that it will be lower than this. At 5, I will be, okay, I should make like this. At 5, my gain will be lower than what my gain was here. How can I say so? Let's just write it. This is 3 and this point is 5. Okay. So after 3, what I am getting? Minus 20 dB per decade. Why so? Because there are two poles, right? Now at minus 5 as well, I am having again one more pole. So I will have more. So minus 20 is already there and minus 20 also will be added. So it will be minus 40 dB per decade. Yeah, so I asked you the question that how can I say that this value will be lower than this value? Because if you are rising from 2 to 3 with this slope, you increase this much. You increase this much. When you are rising from 2 to 3, you increase this much. That means when your frequency got 1.5, you increase this much. Now your frequency is getting 3 to 5. That means it is greater than 1.5. From 3 to 5, if you multiply 3 with 1.5, you will get 4.5 only. So you are going from 3 to 5. That is, you are going more with the same negative slope. So this much value you won last time. Now this much value you lose. First you gain this much of value. Now you will lose more values because you are going more. From 2 to 3 you are going 1.5 times. Now from 3 to 5 you are going more times, right? That means you will lose more. Got my point? Did you get it? From 2 to 3 I am going. That means in the denominator I am going to type log 3 by 2. And from 3 to 5 I am going. That means I am going to write log 5 by 3. Which value will be greater? This is 1.5. This is 1.33, I guess. Yeah. So this value is greater. That means the upper value will be lower. Got my point? Because my slope is 20 equals to y2 minus y1. Y1, this is some value that I will write 7 upon log 2 3 by 2. And for this also I will write the value. So this value is high. So this value will come here. So total value will be high. And from high, minus 7 is getting subtracted. Yeah. Yeah. It's fine. Yeah. So are you getting my point? So same you can do with that with these points as well. Okay, or intuitively also you can think that from 2 to 3 you are going 1.5 times and from 3 to 5 you are going more than 1.5 times, right? From 3 to 5 if you are going more than 1.5 times, so you will lose more, right? And then at 5 you are having a slope of more minus 20, right? So initially 0, then you had a slope of plus 20, then you had a slope of minus 20, then you will have a slope of minus 40. Okay. Now draw the Bode plot for this. So this is an interesting question. Okay. So what you will do? Okay. What is your DC gain now here? DC gain. DC gain is infinity. That means infinity dB. So tell me, shall I start the graph like this? At zero frequency, I am getting infinite gain. So like this, and then I am having a infinite gain. Sorry, like this, and then at 2 I am having a pole. Where are my poles? There are two poles. Poles are at 0 and minus 2. So initially there is a pole only, so I will have minus 20 dB per decade. Then again I am having one more pole at 2, then I will have more minus 20, that means minus 40 dB per decade. So why did not I join this line like this? Because the gain is infinity there, right? So I can't join the line. But is this graph correct? Is this graph correct? As I said that at omega goes to 0, I am having an infinite gain. But this is not omega goes to 0 in Bode plot. This is omega goes to 0.1. In Bode plot, this point is omega equals to 0.1, not omega equals to 0. Are you getting it? This point is omega equals to 0.1, not omega equals to 0. But many times interviewer also forget this point. Okay, if you are writing a gate exam or if you are writing a good level of exam, then they will not do these kind of error. They will certainly start from 0.1 or 0.01 or 0.001, but not certainly from 0, because we know that over omega equals to 0 will be here. Because if I put omega equals to 0, what my log scale will think? My log scale will think that minus infinity is applied, and minus infinity for log scale is here. So this is the place of omega equals to 0. So they can start from 0.1, 0.001, 0.00001, but not from omega equals to 0. But many times it may happen that even your interviewer forgets this. He will say that this is omega equals to 0 only. So what you will do in the exam, okay, this is not the correct one. First you will draw the correct one. In the interview, first you will draw the correct one and you will tell him something that I will tell you. Okay, so let's draw the correct one first. How to draw the correct one first, that I will tell you now. Okay, so this was the point 2. This was the point 2. This slope was, initially I was having minus 20 dB per decade because I was having a pole at 0, and then I was having minus 40 dB per decade because this was continuing and one more came. In this graph, this was 0, then I was having only one pole till this point, then I was having one pole and two zeros at this point. Sorry, I was having only 1 0 at this point, then I was having 1 0 and 2 pole at this point. So plus 20 minus 40, that means minus 20. Now I am having 3 poles and 1 0 at this point. At this point I am having 3 poles and 1 0, so minus 40. Got my point? So that's how the slope will keep on getting added. Okay, now let's make the exact graph. Okay, so how will we make the exact graph? So I need to find the gain at omega goes to 0.1. Okay, so what will be my gain at omega goes to 0.1? 2 upon 0.1 plus 0.1 whole square plus 2 whole square. Okay, so whenever you find, listen to my line very carefully, whenever you find any pole at omega equals to 0, whenever you find any pole at omega equals to 0, okay, apart from this, put s equals to 0. Why so? Because this value is very low with respect to 4. 0.1 square will be 0.01, and this value is very low with respect to 4. So in Bode plot, this assumption is made that if you are finding that gain here, that means apart from this, all the s will be replaced to 0. Are you getting my point? Apart from this, all the zeros will be replaced to, all the s will be replaced to 0, because they will be in addition to something, and with addition to something, that will be much lesser than any other value. Are you getting my point? Okay, so rest of these will be replaced to 0. So this will become 2 upon 0.1. This s will not be replaced with 0. Okay, this will be 0.1 only. S equals to j omega, I am talking about the magnitude, so s equals to omega only if I am talking about the magnitude. So omega value I am putting, that is 0.1. Okay, and this s will be replaced to 0, so it will be 2 only. So the gain I am getting is 10. That means 20 log 10 means 20 dB. Okay, so I will write it on next page. Gain at omega goes to 0.1. I am here we have pole at omega equals to 0. Okay, this is known as type 1 system. Okay, type 1 system. If you are having two poles at omega equals to 0, like this was something like this, then it was type 2. If it was like this, it was type 3. Okay, the number of poles are here, the number of poles are 3, but s square is there, so it is type 2. Okay, so this is system is known as type 1 system. Okay, so in these kind of system, put all s equals to 0, but not this one, not this one. Put all s equals to 0, but not this one. Okay, so my t of j 0.1 would be 2 upon 0.1, and that s would be equals to 0, so it would be like this 10. That means 20 dB. Okay, so how will I draw it? On the next page only I will draw. This one was not actually correct, not correct, right? But many times even in the books as well, and even for the interviewer, this is correct. Okay, so while drawing this graph in the interview, what you will say? You will say that, sir, omega equals to 0, since this is a semi-log graph paper and this is a log scale, that means my omega equals to 0 will lie somewhere here. This point I am taking it as omega equals to 0.1, and my gain at omega equals to 0.1 is some finite value, that is 20 dB. This gain is 20 dB. Okay, so considering omega equals to 0.1, I am starting it from a finite value. Okay, and in the interview, you don't need to find this value. Okay, you will just say 0.1, I am starting with a finite value. You don't need to find this is 20 dB. You don't need to tell that. You just need to say at 0.1 I will have a finite value, so I will start from here. So 20 dB, that you don't need to find. Okay, because in interview there will be variable like SRC plus 1, SR1C1 plus 1, like that. There will be variables. Okay, note the values. So there you don't need to find the value at 0.1. Okay, so you will just tell them that at omega equals to 0.1 I am having a finite gain, and then I encounter what? Yeah, so initially I am already having a pole. That means I will have at omega goes to 0 only I am having a pole, so I will have minus 20 dB per decade. Okay, minus 20 dB per dec, and then at what, at 2, at omega goes to 2 I encounter a pole once again. So at omega goes to 2 my gain would be negative actually. Okay, so at omega goes to 2 I encounter a pole again, so my slope will decrease further, so it will decrease more. I hope you guys must have understood why the gain at omega goes to 2 is negative. Did you guys understand? It will be minus 40 dB per decade. Did you guys understand or not? Because at 0.1 you are having 20 dB, right? So if you go 10 times, from here to here, if you go 10 times, you will lose 20 dB. 20 dB per decade. So at omega goes to 1, you will be having 0. 20 dB per decade. That means from 0.1 to 1 you are going. That means you will lose 20 dB. So at omega goes to 1, you are having 0 dB. So at omega goes to 2, what you will be having? Minus 6 dB. Because minus 20 dB per decade is equals to minus 6 dB per octave. So if you go double, you lose 6. If you go 10 times, you lose 20. Right? So here the gain would have been minus 26. If your concepts are too much clear, okay, then you can write down like this. But if you are a gate aspirant, you will be studying all this in control system again. So no need to worry. This Bode plot concept will be much clear to you when you study in control systems. Okay, but for placement guys, this much is not necessary. They will not ask you what will be the gain here, what will be those conditions, these conditions. They will just give you RC circuit and they will ask you to draw the Bode plot. That's it. And those RC circuit I will discuss in the next lecture only. Okay, So no need to worry. And gate aspirants should not also worry, because they will be studying this again in control system. And for placements, guys, these things will not be asked much. I'm telling these concepts just that you get comfortable with the topic. And I hope everything you are understanding everything. There is nothing that it is difficult or anything like that. I hope you are understanding everything. Just the concept I am telling, right? Let's move on to the now next question. Now you have to find the number of poles and zeros of this transfer function. So try it on your own and tell me how much poles and zeros will be there. So first there is a DC. Then I have a slope of 60 dB per decade. That means I am having 3 zeros. Then tell me at this point how many poles are there. You have a slope of 60 dB per decade. If there was no pole, there was no zero, it should have been going 60 dB per decade. But you see a decrease in the pole, that is minus 20 dB per decade. So there would have been 4 poles, right? There would have been 4 poles, because this will give you plus 60 and this will give you minus 80. 4 poles will give you minus 80. So then you will have minus 20 total. Are you getting it? Right? And tell me what you will have at this point. From minus 20 to 0 you are going. That means there would be 1 0. So basically 4 0 and 4 poles. Right? Now this is the question. In this question, till this point you are having 4 zeros and 4 poles. 4 zeros and 4 poles. Now again there is plus 20 dB per decade. That means there is one more zero. So basically there are 5 zeros and 4 poles. Right? Tell me about this question. Initially you are having 3 zeros, then the slope is negative. So there are 4 poles, minus 20. If this slope was minus 40 dB per decade, that means there was 5 poles, right? Because from plus 62 you are going minus 40, right? From plus 60 to you are going minus 40. So there has to be 5 poles, right? So how much slope you are losing? That is, you are losing 100 slope, 100 dB per decade slope. That means there has to be 5 poles. Are you getting this point? So for omega equals to infinity, if the slope is 0 dB per decade, at omega equals to infinity, in this example, if the slope was 0 dB per decade, that means the number of poles and zeros are equal. So at omega goes to infinity, the slope is 0 dB per decade. Here the slope is 0 dB per decade. So the number of poles and zeros are equal. Number of poles is equals to number of zeros. Now tell me what will be the condition in this case. The number of poles will be greater than number of zeros. Don't go in the previous example. Just think the final slope is negative. That means your graph can go something like this. Like this. Okay. The statement is written for omega goes to infinity, the slope is negative. That means your graph will go like this. Like this. So here there is no pole, and here there is one pole. It can be one pole, it can be two pole. The slope can be minus 120 dB per decade as well. If the slope is minus 20 dB per decade, that means there were 6 poles, but there are no zeros. So basically you can say that your number of poles is greater than number of zeros. Or in the previous example also you can see, when there is at infinity there is this negative slope, so zeros were 3 and poles were 4. So that means number of poles were more. Now in this case, number of poles will be lesser than number of zeros. That means number of zeros will be more, right? Because that finally your slope is positive. So like this, and it will go like this. So slope is positive. That means it will go on like this. So if this was 0 dB per decade, that means there was no zero, no pole. But here at this point omega z, you encountered a 0. That's why your slope is positive. Okay, so slope is positive. That means number of zeros are more. I hope you are understanding all these examples. Okay, we are going a bit fast. We are not getting into the depth, but actually the conceptual understanding you can have. 60 dB per decade matlab means 3 zeros. Then I am having minus 20 dB. That means I lost 80 dB per decade. That means there has to be 4 poles. Then I again went to 0 dB. That means I gained 20 dB per decade. That means there has to be 1 0. Okay. First 60 dB, then I lost 80 dB, then I again gained 20 dB. So that means 3 zeros first, then 4 poles and 1 0. Similarly, here as well. And here as well, I again gained 20 dB. That means there are more number of zeros than poles. Okay. Let's talk about the Bode phase plot now. Okay. Let's study Bode phase plot now. So the thing is, this is not mainly asked in the interview or even in the exam also. You will see in the gate exam or any other exam. Bode phase plot is not discussed that much. Bode magnitude plot is discussed. Okay, but not the Bode phase plot sometimes. Okay, but still we will study. So tell me, what is the angle of this? Okay, one thing I wanted to ask. What will be the angle of this? You guys can write like the angle of this minus the angle of this, right? So if there are two angles in the multiplication, they will be subtract. Sorry, if there are two angles in the divide, they will be subtracted, and if there are two angles in the multiplication, they will be added, right? I hope you guys know this concept. So T of j omega will be j omega tau. Sorry, this is not angle. This is T of j omega only. J omega tau plus 1. So what will be the angle? T of j omega will be tan inverse omega tau. So at omega equals to 0, your angle is 0 degree. At omega equals to infinity, your angle is minus 90 degree. So from 0 degree to 90 degree you are going. This is the exact plot. This is not the Bode plot. In Bode plot, there will certainly be some assumption because Bode plot is a approximate plot. Okay. From 0 degree to minus 90 degree you are going. Zero degree to minus 90. Okay. This is the exact phase plot. Now let's draw the Bode plot for this. The same function is there. Instead of 2, I am writing 2 here. 2 I am writing. Now you have to draw Bode phase plot. Okay. So what I will do? What is the angle? Angle is tan inverse 2 omega. Right. This is the angle. Tan inverse 2 omega. Okay. So first task would be to find the 0. Where is the 0? 0 or pole, whatever there is. So where is my 0? Omega z. That is at minus 1 by 2. Okay. So, and this is my angle. So first I will check at, I am writing at omega equals to 1 by 2. What will be my angle? Angle would be, okay, instead of this I can make a table. This will be more good. I am going to write the values of omega and I will ask you the angle. First I am writing omega equals to 1 by 2. What will be the angle? Tan inverse 1. That means 45 degree. If I am writing 1 by 2 by 10, that means 1 by 20. Okay. Put tan inverse 2 into 1 by 20. That means what was my 0? 1 by 2. And I am multiplying it with 1 by 10. At that point, I am taking the value. So 1 by 20. So put tan inverse 2 into 1 by 20. So it will be tan inverse 0.1. What is the value of tan inverse 0.1? Calculate it in your calculator. 0.1 tan inverse. This is 0.09. 0.09. That means I can put it as 0.1 degree. Nearly equals to 0 degree. Right? Now I am putting 10 times of my pole. Sorry, 0. 10 times of this. 10 times of this. Okay. This is tan x and this is 1 by tan x. Okay, so put tan inverse at omega, you will put 10 by 2. So find the value of tan inverse tan. Tan inverse tan. Wait. Okay, this value was not in degree actually. I matched it up. 1 by 20. This was 2.886. Really sorry. Like this is very low. 2.86. I can write very low. Very low. 2.86. This is very low. Approximated equals to 0 degree in Bode plot. And this is 45 degree. Okay. And this is nearly equals to 90 degree. Let me check what value I get. 5 tan inverse. Okay, 10 tan inverse. Sorry. We're getting 84.28. 84.28. Approximated taken as 90 degree in Bode plot. Okay, 90 degree in Bode plot. So how will you draw the Bode phase plot? Are you getting some idea? What you will do? This is the angle, right, in degrees only, and this is the value of omega. First you will find your pole or 0, whatever it is. So here my 0 is at 1 by 2. Okay, my 0 is at 1 by 2. At 1 by 2, and then I will put 2 more points. 10 times less, I mean 1 by 10 times, 1 by 20, and 10 times more. That means 10 by 2. Okay. So before 10 times less, I am having 0 degree. Before 10 times less. That means before this, I am having 0 degree. Then I will have a slope, because till 10 times, till this point I need to increase it to 90 degree. Till this point I need to increase it to 90 degree, and after that it will not increase further. And at 1 by 2 I know at my 0 location I will be having, at my 0 location I am having 45 degree. That I know. And here I am having 90 degree. That also I know. And here I am having 0 degree. That also I know. This is my 0 degree. That I know. This is my 45 degree. And this is my 90 degree. So tell me, what is this slope? Can anyone tell? What is the value of slope? 45 degree per decade. If you go 10 times, 1 by 2 to 10 by 2, you are increasing 45 degree. You are going from 1 by 2 to 10 by 2. That means you are increasing 45 degree. So your slope is 45 degree per decade. After that, the maximum value it can get is the maximum value at omega goes to infinity. At omega goes to infinity, this will be 90 degree only. The maximum value it can. What I am doing here? Why is it negative? This is positive. I don't know. This is 3 o'clock at night and I have to record the videos. Yeah, this is what happens when you work with when you are already working. So this is what happens sometimes. Okay, I'm really sorry for it. This should increase like this. Okay, so it should increase like this. And the maximum value it can get is plus 90. Similarly, the maximum value it can get is plus 90. So what you will do, first you will find the location of pole or 0. Okay, so as 0 will give you n zeros. N zeros will give you n zeros will give 45 degree n per decade slope, and similarly n poles will give you minus 45 degree n per decade slope. So I will see the example of now. poles. Okay. So what is the location of pole here? Forget about the DC gain. DC gain doesn't matter in case of angle. Like if this is the case, what will be my angle? It will be tan inverse 2 by omega minus tan inverse 3 by omega. Even if this gain is tan, even if this gain is 100, even if this gain is 10,000, the angle will not change, because at this the angle doesn't change. Angle doesn't depend on the DC gain. So we are not going to find DC gain here. Only the location of pole, that is minus 1 by 2. Okay. So what will happen? Okay, like previous example, I can make a table here again. The value of S and the angle. What is the angle this time? The angle of j omega is minus tan inverse 2 omega. So I can put the value of 1 by 20, 1 by 2 and 10 by 2. The values of angle that I will get is minus 2.86 degree, minus 45 degree, minus 84.28 degree. This will be nearly approximated to 0 degree. This will be nearly approximated to minus 45 degree, and this will nearly be approximated to minus 90 degree. So how will I draw the Bode plot? What I will do, I will always first I will go and mark my pole or 0. This was my pole, and here I was having 1 by 1/10 of this, and here I was having 10th of this. This was my omega value, and this is my angle value. So before that, before this, everything was 0. Okay. And then I know one thing, that I need to go till minus 90. I need to go till minus 90, and 10 times of that I will go to minus 90. And then it will be saturated only. Okay. And this point is minus 90 degree, that I know. And what about this point at 1 by 2? This point is minus 45 degree, that I also know. Okay. This point also I know. Well and good. So what is this slope? If you are going 10 times, you are losing 45 degree. That means the slope is minus 45 degree per decade. So n poles will give you minus 45 n degree per decade slope. Okay. Now let's solve a problem where both poles and zeros are there. Okay. In this problem, pole is also there and zero is also there. So like in Bode plot, what did we do? If we were asked to draw the Bode plot of this, what did we would have done? First we find the DC gain. DC gain is 0 dB. DC gain is 0 dB. Okay. Now what I will do? At 5 I am encountering a pole. So minus 20 dB per decade. Then at 500 I am encountering a 0. Then minus 20 plus 20, that means 0 dB per decade. So this would have been that Bode magnitude plot. But whenever you are drawing phase plot, never try to do it together. Solve separately for pole, solve separately for the 0. Separately for pole, separately for the 0. And then see what you can do. Okay. So let's just assume I can write my TS as T1S into T2S, where my T1S is 1 plus S by 100. So this I will solve for pole, and my T2S is 1 plus S by 1 upon 1 plus S by 5. 1 upon 1 plus S by 5. Okay. So what will be the angle of TS? The angle of TS will be T1 of j omega. If they are getting multiplied, that means angle will be added. So basically you draw the Bode plot for this, to draw the Bode plot for this, and just add them up. Getting my point? Draw the Bode plot for this, draw the Bode plot for this, and just add them up. Okay. So how will you draw the Bode plot for this? S by 100, not S by 100, S by 500. I will draw for T angle of T1 of j omega first, and then angle of T2 of j omega first. Angle of T1 of j omega. This will be angle of T2 of j omega. Look, if you don't know anything about the angles, please do watch any YouTube video where just type magnitude and angle of a complex variable. You will get the video, and just watch those video and you will be more clear. Okay, angle and magnitude of any complex variable. Okay, from there your concepts will be clear about the angles, because this is a very basic concept. That's why I am not dealing it here. Okay, very basic. That's why. Or I think I will have to make a video as well for this, because I'm really starting from very zero. That's why. Yeah. So we are making for angle of T1 of j omega. Okay. So what is the location here? My 0 is at 500, minus 500 you can say, and here my pole is at minus 5. Okay. Let's just assume this is my 500. So 10 times more 5000, and 10 times less 50. How will I draw? Before 50 nothing will be there. After that it will rise with 45 degree per decade, and I know one thing, it will be saturated to 90 degree angle. This value is 90 degree, and here I will be having 45 degree, and the slope is 45 degree per decade. What is the slope here? 0 degree per decade, right? Because this is not actually moving, this is saturated. Slope here as well 0 degree per decade. Only in between I am having 45 degree per decade. Now what about T2j? Point, one point here, other point here, that is 0.5, another point here, 10 times, that will be 50. Okay, 10 times point will be 50. Tell me, how will the graph go? Before 0.5 nothing, then minus 20 degree per decade, minus 45 degree per decade, then again 0 degree per decade. That's it. This is your 0 degree per decade. This is your minus 45 degree per decade. This is your again 0 degree per decade. What is the value here? That is minus 90 degree. Now what I need to do? I need to add them up. Now this is the task, how to add them up. How to add these two graphs. Okay, so whatever the points are there, I will write down those points. So starting from 0, then the next point is 0.5, right? Then the next point is 5, then the next point is 50, then the next point is 50, 500 and 5000. 500 and 5000. All will be at equal place, right? Delta, 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 because this is log scale. 10 times, 10 times, 10 times, 10 times. These are the values of omega, and this is the T of j omega now, right? This 0 was for this, it should be near to this, and this pole was for this, so it should be near to this. Okay. So in this graph, you are going from 0 to 0.5, you are having 0 degree angle. In this graph, if you are going from 0 to 0.5, the 0.5 will be somewhere here. So you are having 0 degree angle. So 0 degree here. Okay, well and good. 0.5 to 5 minus 45 degree per decade slope, minus 45. Here you are having 0 degree per decade. So it will go like this only. Look, I will ask you a question. If you are adding y equals to 5x, y1 equals to, and y2 equals to 8x, you are adding both of the graph. What you will do? This is your graph y equals to 5x, and the other graph is y. This is your graph y equals to 5x, and the other graph is y equals to 8x. If you are adding both of them, the slopes will be added. Y1 plus y2 would be 13x. So for the final graph, your slope will be 13, right? So your slopes are added. Whenever you add two graphs, your slopes are added always, right? So here as well, your slopes will be added. So here minus 45 degree, here 0 degree. So eventually it will be minus 45 degree only. Until 50 it will be minus 45 degree, and till 50 it is 0 degree only. So minus 45 only till 50. So this slope is minus 45 degree per decade only. And what will be the value at minus at 50? That will be minus 90 degree. Why it is minus 90? Because here I am having minus 90, here I am having 0, so it will be minus 90 only. Or by the graph also, by the slope also you can see. Now here the slope is 0 degree per decade. After everything, the slope is 0 degree per decade. Just minus 90 will be added. But don't forget about this, just add the slopes. This is 0 degree per decade and this is 45 degree per decade. So now you are having 45 degree per decade slope, right? Now you are having 45 degree per decade slope. So the slope will be here, that will be 45 degree per decade, and it will go till 5000. And after 5000 you are having 0 degree per decade slope. So just keep on adding the slopes. That's it. 0 and minus 45. That means till this point you are having minus 45. Now after 50 you are having 0 degree slope here, and here you are having 45 degree slope. So 45 plus 0, that means plus 45 degree slope. And after 500 and after 5000, here you are having 0 degree, here also you are having 0 degree. That means this is 0 degree slope. So this is your plus 45 degree per decade slope, and this will be your 0 degree per decade slope. And also you can recheck minus 90 plus 90. At omega goes to infinity, you are having 90 degree angle, and at omega goes to infinity, you are having minus 90 degree angle. So 90 minus 90, that means 0 degree angle. Yeah, you are having 0 degree angle. At omega goes to infinity, you are having 0 degree angle. Also, you can put here as well. At omega goes to infinity, if you put, what will be the condition? S by 500 upon S by 5. So it will be some 1 by 100. So independent of the frequency, that means angle is 0 degree. Okay, so at omega goes to infinity, you are having angle 0 degree. So this is how the phase plot looks like. Okay, just add the slopes. That's it. Nothing else. Just add the slopes. We will take another example. Okay. So in this case, two there are two poles. Okay. So I will make for the separate one. First, I will make for this. The angle is minus tan inverse omega, and then I will make for this. Both of them I will make. Basically, what I am doing, I can write my T of S like A1 upon S plus 1 into A2 upon S plus 5. So first make the body plot for this, then for this, and just add them up. Then add the angles. Okay. T1 of j omega, T2 of j omega. Okay, so first I will make for A1 upon S plus 1. So always prefer two different curves. Okay. When you are drawing phase plot. In case of magnitude plot, you can draw it in one curve only. But in case of phase plot, I will always say prefer two curves. Okay. So this point is 1. This point is 1. then 10 times of this, and then sorry, this is 1 by 10 times, and this is the 10 times. Okay, before this there will be nothing. Okay, what I will do to make it more interesting, what I will do, I will do this now. Okay, s plus 1 whole square is there. What will be the angle here? It will be minus 2. Okay, so if there are two poles, two poles at omega equals to, two poles at omega equals to 1, two poles at omega equals to 1. There are two poles at omega equals to 1. So what will be the slope now? Tell me, what will be the slope? The slope will be minus 90 degree per decade. Minus 90 degree per decade. And here the slope is 0 degree per decade. What is the value here you expect? It will be minus 180 degree. Right? Put omega goes to infinity in this case. Omega goes to infinity. This will be 90 degree. 90 into 2 minus 180 degree. So the angle is minus 180 degree. At omega goes to 1, how much angle do you expect? At omega goes to 1, how much angle do you expect? At omega goes to 1, I would expect minus 90 degree. Right? Put omega goes to 1 here. Tan inverse 1 is 45. 45 into 2 minus 90. Because here it was 0 degree and the slope is minus 90 degree per decade. That means in one decade, minus 90 should increase. So this point should be minus 90 degree per decade. So this is what I am having. Right? So this is the graph for this one. And now the graph for the other one. That is also a pole, but pole is at 0.5. So this is the 0.5. This is the 5. 1 by 10 times will be, and this is the 10 times. Since there is only one pole at omega goes to minus 5, I should write, and minus 1. Omega goes to minus 5, only one pole is there. The slope is, what is the slope? The slope is minus 45 degree per deck. Okay, and this will be 0 degree per deck. Now I will add them up. So how to add them up? That we will see. Okay, this will be your angle of T of j omega. We are starting from 0, and then this point will be 0.1, this point will be 1, and in between 0.5 will come. I write this will be 0.5, then this point will be 0.1. Then what point I need to consider? Then I need to consider point, this point is 1. Then I need to consider 5, 10 and 50. This point will be 10. This point will be somewhere here. This point can be 50. And in between I will have a point 5. So all these points I will consider. So now I will start from 0 to 0.1. 0 degree, 0 degree. And then 0.1 to 0.5 as well, it is 0 degree only. The slope is going to be 0 degree only. Till 0 to 0.5. 0 degree, 0 degree. Now 0.5 to 1. So from, wait a minute. From 0 to 0.1, it is 0. And from 0.1 to 0. So from 0 to 0.1, this is 0, this is also 0. Okay. Then from 0.1 to 0.5, this is minus 90 and this is 0. So here I will have minus 90 degree per decade. This slope is, if this is minus 90 degree per decade, I have to make it more like this. Okay. This is minus 90 degree per decade. Now from 0.5 to 1. From 0.5 to 1 we are going. So here I am having minus 90. and here I am having minus 45. From 0.5 to 1, 1 will be somewhere here. So minus 90 plus minus 45, that would be minus 135. So it would be somewhat so better than this. I can change this slope. This slope is like this only, just to make the better diagram I am doing it. Okay, the slope is minus 90 degree per decade only. Now my slope is between 0.5 to, what is 0.1 here? What did I do here? 0.5. Then the next point I want is 1. Zero point 0.1 I want, 0.5 I want, then I want 1, then I want 5, then I want 10, then I want 50, right? So 0.5 to 0.1, this is minus 90 and this is minus 45, so minus 135 degree will be there. Look, this diagram is going a bit kind of minus 135 from 1 to 5. Tell from 1 to 5 what is happening here. Minus 90, here also minus 45, that means it will also be minus 35, minus 135. From 5 to 10, from 5 to 10, here minus 90 and here also minus 45, so it will also be minus 35, minus 135. This slope is minus 135 degree per decade. It changes from here and it goes till here. From 10 to 50, from 10 to 50, this is 0 degree, and this is from 10 to 50, this is minus 45. So you will have minus 45 slope now. Now, how can I make it? I will make it on the next page only. Okay, I will take it to the next page. There I will make it. From 10 to 50, this slope is minus 45 degree per decade, right? Just with the slopes we are playing. From 10 to 50 it was 0 degree per decade, and from 10 to 50 it was minus 45 degree per decade. And then after 50, this is also 0 degree, this is also 0 degree. After 50, everything will be 0 degree per decade. This is 0 degree per decade. Without calculation, without going to the formula, let's assume, try to find out what is the angle we will expect here. Okay. So we are going from 0.1 to 0.5. We are going 5 times with this slope, 90 degree per decade slope. We are going 5 times. Okay. So we don't know any formula for 5 times. We know for 10 times only. Right. For 5 times we don't know. We have to find the value. This is 90 degree per decade. Slope is there. Y2 value I need to find. Y1 value I need, that is 0. And log 10, 5 it will be. Okay. 5 into log into 90. So nearly they are saying minus 62 degree. We can take minus 65 degree. Okay, nearly. Okay, so here I am having minus 65. Now I am going from minus 0.5 to 10. So if I go minus 0.5 to 5, I know that I will decrease by minus 135 degree. If I am going from 0.5 to 5, then if I go from 5 to 10, that means I am going double, and the slope is minus 135. So 2 log 10 into 135. So I will lose another minus 40. And if I am going from 10 to 50 with 45, that means 5 log into 45. Another 30 degree I will lose. So 140, 240, and another 30, or yeah, 240 and another 30 I will lose nearly. So nearly this angle should be minus 270 degree. Look, I just applied those formula, nothing else. Like if I know the angle of this point, I can find the angle of this point, right? I know the slope, right? Y2, this point is Y2, let's assume. If this point is Y2 minus Y1, this point is 0. Then log 10, this point is 0.5 minus this point is 0.1. Log 10, 0.1. And the slope is minus 90 degree per decade. So that's how I find it. Okay. So nearly it came minus 65 degree. Now I need to find the point of this. Then from here I observed one thing, that 0.5 to 5 I am going, I am increasing by 10 decade. Right? 10 decade. That means I will lose 135 degree. Okay, 135 degree. Now I am going from here to here. Double I am going. Right? Double I am going. And the slope is minus 35. So I will lose minus 35 into log 2. This much I will lose. Why so? You can do it. Y2 minus, let's just assume this point is Y2. This point you know, whatever it is, Y2 minus Y1, whatever it is, upon log 10 by 5, that will be log 2, and the slope is minus 135 degree. So what you will lose? From Y1 you will lose minus 135 into log 2. So this is what I put here. And then from here to here you are going, you will lose minus 45 into log 5. So this much you will lose. So nearly it is coming around 270 degree. Okay. So at omega goes to infinity, nearly your angle will be 270 degree. And if you put in this expression at omega goes to infinity, this will give you minus 180 and this will give you minus 90. Okay, so minus 180 minus 90, that means minus 270 only. So this graph is correct. So this is how you draw the phase plot. I hope you have understood the concept. Even if you didn't understand it, no need to worry. Okay, there are a lot more things that you can understand. This first thing is that this is a kind of complex concept, and we are not studying it from very basic, right? Because we can't really study that. This much is not required for your placement. So this is the max that is required for your placement. They will not ask anything more from this part in your placements. Okay, they will not even ask phase plot, that I am pretty sure. And in analog electronics, we will not draw phase plot. We will only plot what? Magnitude plot. These magnitude plots that we draw here. These These magnitude plots are important. When there is 0, you give 20 degree per decade slope, and when there is a pole, you give minus 20 dB per decade slope, and you keep on adding the slopes. Okay, you encounter a 0 plus 20 degree per decade. You encounter a pole plus 20 minus 20 0 degree. When you encounter another pole, that means 0 minus 20 minus 20 degree per decade. Now you encounter 4 poles. Minus 20 is already there. 4 poles are there, so minus 80. So minus 20 minus 80 minus 100 degree per decade. Okay, so that's how we will draw the graphs. Okay, for phase plot, for not for phase plot, for magnitude plot. And I guess I talked about degree per decade, but it was dB per decade. 20 dB per decade minus 20 degree dB per decade minus 40 dB per decade. Okay, so I am kind of a bit tired now because it's been 5 hours since I am recording the videos. Yeah. So yeah, that's it about the control theory part. In the next video, we will see the filters, which I have already recorded just now. So in the next video, you will see filters. That is very important concept, and that is also a very good concept as well. You will find it very interesting. Okay. So in the next video, you will see filter design, and I hope you have understood all this lecture. Okay. So I will give the notes, and then you can move on to your next lecture. Okay. Thank you.